Hey everybody, so in this video we're going to be going over EasterBunny, which is a easy hack the box web challenge. It's being retired today. If you look at it, looks like most people thought it was a fair bit harder than easy. I thought it was a really well designed challenge. I thought it had some cool stuff going on in it, and I think it'll be a fun one to look at. So yeah, let's just go ahead and do that. So if we look at the site, I've already got the instance started here. We will see that it's a pretty straightforward website. You can write a letter to the Easter Bunny. Dear Easter Bunny, please give me eggs and like and subscribe. And then you can mail off your little letter to the Easter Bunny, and then it should show you, it's sending it, should show you a little preview of it. Or not preview, but the actual letter itself. And yay, that's the website. Sending letters to the Easter Bunny, and you can look at other letters. Like, let's see what letter 1 was. Here's someone, letter 1's letter. So yeah, there you go. So like most Hack the Box challenges, web challenges, we are actually also given the files, the source code for what's being run. So this is going to allow us to analyze the source code, look for the vulnerability, which we can then exploit to get the flag. That's kind of how most web challenges work. It's what's called white box, where you actually have access to the code, as opposed to black box, which is you don't. I think this is really good for these challenges because being able to read and understand code and look at the code is a really valuable skill, and actually getting the experience of kind of seeing how things are implemented that cause vulnerabilities is only going to help you when it comes to actually doing black box stuff. So let's go ahead and look at the code. So I've already downloaded the source code and unzipped it. And the first thing I'm going to do when looking at the source code is look at the Docker file. The Docker file is the main set of instructions that build the image that's going to get used for the container. So this is like the, I don't know, the scaffolding or the foundation, or it's like the best overarching look at what's kind of actually going to be going on with this machine. So we can see that it's using the base node image. It's installing Chrome, it's installing Varnish and Supervisored. So Varnish is like a web cache reverse proxy, which I'll talk about in a minute. And then Supervisored is like a Linux program for kind of managing processes. And we can see it's just putting in the configuration files. It's doing the typical things you're going to see, where it's moving all the, it's making the directory, moving in all the challenge files, installing the stuff it needs to install. It's opening up port 80, and then the command. This is the kind of what's going to get run when the container starts up, and it's going to run the supervisored, which if we look at, it's starting up node, and it's starting the varnish, which these here is just telling it to look on port 80. This is the configuration file it's going to use. And then this, I believe, is telling it how much storage to allocate for the caching, I believe. So a web cache or a reverse proxy, if you're unfamiliar with, I made a very detailed graphic to help explain it. So essentially, here's you browsing the internet, and you're going to send a request to the Easter Bunny, right? You want to send the Easter Bunny your letter. Well, it's going to get sent. It's going to hit that reverse proxy. And then from there, the proxy will either forward it to the back end server. There could be multiple servers here. It's going to handle where do I put it? This is sort of your kind of point of contact, and then it handles everything behind that. And caching kind of lets it speed up. If there's kind of a request that it doesn't want to have to keep going to the back end to get, because then that's resource intensive, right? The back end has to generate it. There's this extra communication. It's kind of a lot like, I don't know if you've had the experience where like you touch like a hot stove and your hand jerks away and then you realize like it was hot. That's kind of the same thing here, right? Like your body does that because so the signal from your finger like travels through your body up through the spinal cord to get to your brain. But in the spinal cord, there's like these neurons that can go like, oh no, that's hot, like jerk the hand away before the signal even gets sent to the brain. So like it doesn't have to travel that extra distance. It doesn't have to use the brain computational power to be like, oh, this is hot, we should move our hand. Let's now send the signal back to the hand to move the hand. Like all that takes longer, and the less time you're actually touching the hot stove, the better, right? So like a web cache is kind of the same thing. It is speeding everything up because it is not bothering the backend servers with having to generate requests, all that extra communication. It's just delivering the response for cached based on whatever criteria you set. Like there's configuration file, there's all kinds of different things you could do in order to be like, no, let's cache these responses, and that can drastically speed up the performance of like the whole system. So that, I guess, in a nutshell, is kind of a reverse proxy and web caching. So this, here's our config file. So that this is what the cached, the varnish cache configuration file looks like, right? It's telling it like, okay, here's where the backend server is. It's on, on this port, and then all the different criteria and stuff. We'll kind of go over that later. If we look at kind of this index file, this is like the main sort of like start of the kind of like node server. This is sort of telling it what to do. So let's say it's using Express, it's using Nunjux, which is like a templating format. There's the database. We can see that starting the server, right? So we knew the backend was on this port, and that's what this is listening on. Then if we look at the database, we can see that that's what's actually storing those letters to the EasterBunny, right? And then this is what's happening when the containers first started, right? When you start up the challenge, it's going to populate it with data already. And we can see there's a message table, has an ID, it has the message, and then it has this hidden value. And if we look here, we can see there's one that has a hidden value of 1, and that's actually the flag. So we know that our goal is kind of going to be to read this third message, and it's hidden, so that's probably going to come into play. Like we're going to have to figure out how to bypass that, or maybe it just is that's the, I don't know what the word would be, like that's the setting that's going to make it hard for us. We can look at, here's the commands for the database, just a couple simple ones. We can get the message, how many messages there are, and inserting a message. And if we look at the statements, we can see they're all properly parameterized. So there's not going to be any SQL injection here. And then let's go ahead and look at the routes file. So this file is what's actually taking care of all the requests, right? Like, so when we visit the letters endpoint, it does this. When we visit the submit, the message. So looking at the submit one, like when we sent the message to the EasterBunny, it was probably a post request to submit. Like we'll look at that in a minute, but we can see here it's going to take our message, it's going to insert that message into the database, and then it does this bot visiting thing. It gives it this like URL. So like if we look at visit, we can see it's being run by the bot.js file in utils. So if we look at that, we can see here it's using Puppeteer, starting up Chrome, And this is kind of typical you'll see in a lot of challenges where it's simulating some kind of user interaction, usually like an administrator or something, which we kind of see here, right? What it's going to do is essentially it just opens up the browser, creates an incognito window, and then sets this cookie with the name of the cookie is auth, and there's this auth secret value, and then it's just going to go to whatever page it's given and then close, shut down. And if we look back at our routes, the page it's going to is that letters ID, which we can see it's just another endpoint, and it's going to go to whatever the last ID of the message was that was inserted into the database. So essentially, it is when we submit a letter, then the Easter Bunny is going to go look at that letter. And so it's going to letters, right? And in letters, we just see this. But if we were to look at the, well, here, let's just look at our requests. So if we look into burp, all the requests that we made when we were looking at the site, we can see, right, like here was that post request to submit. And we can see here's that message we submitted. And then when we went to the letters page, there's obviously some JavaScript or something loading up, because then it loads, it went out and got message 7. Oops, I don't know what I just did. So this is giving it that message. And then like when we went to looked at the first letter, right, we went to letters ID equals 1, and then it loaded message 1. It tells us how many there are and what the message was. So right off the bat, we could think like, well, we know it's message 3 in the database. Let's just go get that. And let's just go ahead and try it and see what happens. It's not going to work, obviously. And we can see, sorry, this letter has been hidden by the Easter Bunny's helpers. And if we go back to the code and look at the code, we can see here when we go to message, right, it's going to take that ID. It's a message that goes to the database and gets the message. And if there isn't a message, it'll get a 404. And then here's where that hidden value comes into play. If the message is hidden and the request isn't coming from whatever this is admin is, then we get that message we got, right? So we were trying to retrieve a hidden message, and we're not meeting whatever criteria this is. If it was a hidden message and we did meet that criteria, right, then it's going to set the cache control headers on the response. And this is basically telling Varnish, don't cache this, right? Because if it cached it, then anyone who came right after potentially could then get it. Otherwise, if it wasn't hidden or anything, it's just going to give us the message, give an error, whatever. So that kind of in the nutshell is just is the main points of the code. So kind of with the overall idea of what the site is and what our objective is, right? Like we want to get the flag. We know the Easter Bunny is visiting the page usually, pretty much always in a challenge like that when there's kind of a simulated user. Somehow we're going to have to exploit that by getting the user, either through like some kind of cross-site scripting vulnerability or, something like that. It's going to take that user's interaction in order for us to exploit it. We know that the flag is only visible to the admin or only visible if you can satisfy that is admin function. So if we look at that real quick, because your first I think most people's typical first thing is to think like, oh, okay, how do we defeat that? How do we pretend we're the admin so then we could access that page? So if we look at the is admin, it's coming from the utils authorization file. And if we look at that is admin function is basically just saying the request has to be coming from localhost, and the request needs to have an auth cookie that is the auth secret. And if we look how auth secret's made, we see it's using 69 random bytes converted to hex. So this here is like pretty secure. It would take a lot if like we were going to try and figure out how to exploit this, right? Like we would, unless there was a vulnerability specifically in this package, like this is far too big a key space to like just sort of do some kind of brute force attack to try and figure out the cookie, the raw secret value for the cookie. And even if we could, the request still has to come from localhost. So we need some kind of also like server-side request forgery or something like that. And then kind of in our head knowing that this is an easy challenge, like this just looks like way too hard. So what do we do? Well, pretty much all web challenges, like no matter what, your kind of first thing you should always think about is what input can I control, and then follow it all the way through the code base. Like 90+% of the time, that's going to be what it takes to get you the flag. And like that's what your first order of thinking should be, especially if you're not sure what to do. Like just figure out what the input you control is, follow it through the code base. Like I say that in every video, and because that's pretty much what you should be doing in these. So what input do we control? Well, we could send the Easter Bunny a letter. That's kind of the most obvious one. And if we go back to that code flow in the code, we can see, like here, let's bring that back up. So submit, right? So this is what we can control. Like we can put, well, actually we can control all of this. We can put whatever we want here, right? We're sending the post request. And if we look at that code, so whatever this message value is what gets, is what's getting inserted into the database. So let's go look at that function. We kind of looked at it earlier, and we know there's not any SQL injection, but like we still want to like go through and look at it. We can see it's just inserting into messages, message hidden, and then there's the parameterized values. Well, you might think like, oh, there's not a hidden, like we're not passing anything else. Like the only thing we're passing in is message. So where's this hidden coming from? How is that getting set? Well, we can read the documentation or do some Googling. Basically, if this value isn't being explicitly set, it'll use the default. If there's a default set, like we could set the default, or they could have. If there's no default set, something like an integer, it's just going to default to the value 0. So essentially, every message that gets added is going to get added with 0. So the only hidden message now is going to be that one. But so we see this isn't really getting us anywhere. It doesn't look like there's anything exploitable in there. We can control, the ID parameter in the message, like we're visiting the URLs. But then there's also this stuff here. If we go to the root or the letters, we can see that it's doing this stuff, which it's rendering a template. So this view letters HTML and index that's using that nunjucks. We talked about that templating engine. And it's passing into this CDN value and then whatever this is. Now, in JavaScript, anything between backticks is what's called a template literal, string literal? I think it's called a template literal. Essentially, it's just a way to build a string with values that like you kind of want the program to fill in, right? So anything between this $sign and the brackets gets evaluated, and then whatever that is gets put into the string. So the string is going to be the request protocol with the request host name, and then the request header that came from this, and then this double quotes thing. So what's that called? A null coalescence operator, I think. Basically, it's JavaScript way of testing. If this value is null, then it's saying use whatever this is, what's after it. And if the value isn't null, then just use this. So if there isn't an X-forwarded port header, this would be null, and so it's going to use 80. If there is, it'll just use whatever that is. So we could control the host name, right? Like we can put what we wanted in. So we could control this. Let's see what this is. We know it's going to a template. So maybe we're thinking there could be something like a template injection or something like that. So let's figure out where this CDN is. We know it's both in index and view letters. So if we go to, let's look at it in the index. And if we kind of look over this, we're not going to see anything same in view letters. But each of these is using the, right, it's extending the base HTML. If we look at that one, we can see this is how it's just setting up kind of the, obviously, the base of the HTML. And here is where we see that CDN passed in, you know, it's put in between the double brackets. So that's tells the template to like do this stuff here. So that string's getting passed in, and that's what's going to be here. And it's being put into this base HTML tag, which if we don't know what that is, like we need to go look that up right now, because we know we can kind of control this. So what is the base? What does base do? And if we look at it, we can go to the docs. The base HTML element specifies the base URL to use for all relative URLs in a document. So essentially what it's saying is, like if we look at this index, right? Like we can see, or maybe view letters is a better one. I was hoping for one. Oh, here, well, I can use this one. So here's the base, right? So this is an absolute URL, right? It gives a protocol, the host, and the port, and the path. This is just saying main CSS. So how does it know where to get main CSS? Like you can't just type main CSS into the internet. Well, it's using that base, and it's just going to append that to the end of it. So if we go back and look in our routes, where was that? Right, it's going to get appended to the end of static. So this is basically just telling it what the base URL to use is. Well, that might give us some ideas, right? Like we could control the host name. So we could put some kind of like host name we can control in, and then it would get, when the page is rendered, it would go to the server we control to get like main.js and viewletters.js. Anything with a relative link, like we could actually control what that content is. So let's go ahead and try it, like test out our hypothesis, see if it's like we're sure we understand this correctly, and can even like exploit that. So let's go back to our browser. First, let's go into burp, and we're going to intercept a request, right? And then let's just go back to letters ID 1. We're going to try and test out our theory. And we are going to change this host header to some value we control, because then what we're thinking is going to happen is that it is going to put that value in here and use that for the base URL, and then it'll go to our website to fetch those resources. So I'm going to put in the IP of a site that I control. Now you might be thinking like, well, if we change it here, how does it, like, won't it just go there and this request go there? Well, since we're using Burp Suite, Burp is smart enough to know like it's going to send it to the exact same place. It's just going to change the host header. So if we do that, actually, let's go ahead too, and we're thinking it's going to load that JavaScript file. What was it called? View letters? It's going to view letters. So let's actually this is just a DigitalOcean droplet that I control. So let's go ahead, and we know it's going to go to static, right? So let's make a static directory, and then let's just test it. We're going to replace that view letters JavaScript file with, it's just going to open up an alert. What was it? View. Was view letter or view letters? View letter. View letter.js. And then we will just start up a web server so that we can see what happens. So we're going to forward this request. And if we're right, here's the web page, right? Our alert popped up, so we know it executed our JavaScript. The page looks like crap, right? Because it didn't load the CSS and all that stuff because it went to our site to get it, right? It tried to load the main. We don't have that. It tried to loaded the view letter, but it didn't get all the other stuff. So we're on to something, right? We have the ability now to get, have it execute code we control. But the problem, if you kind of see it already, is like, this doesn't really help us because essentially we're just hacking ourselves, right? Unless we can get the Easter Bunny before he makes his request to change his host header to some site we control, like, we're not really going to be able to do anything. So what do we do? Well, our advantage in doing challenges like these is we know that it's possible, right? There's a goal, we know what it is, it has to be possible, otherwise they wouldn't have made the challenge. And when they made the challenge, the things they put in the challenge probably going to be used in order to achieve our goal. Now, that's not always the case. You know, there's rabbit holes and, you know, fake paths and stuff like that. But especially on an easier challenge and something as big as like having the, you know, bot go and look at the site. So if we think about it, like, let's run through what's happening in our code, right? When we submit a message, the Easter Bunny goes and visits that message. And he's going to that site that we know has this like vulnerable string in it. Well, if we think about it again, remember when we look back at what's actually going on? Well, the Easter Bunny is going and visiting the site. So, you know, this reverse proxy is handling, you know, all the connections for, you know, everyone across the internet. So the Easter Bunny's request is going to go through this too. So there's something called web cache poisoning, which is if you can figure out a way to poison the cache, then that content will get served for everyone who makes that request. It's a really powerful exploit, right? You can potentially, you know, infect or get many thousands or even like millions of people to get served your like malicious. I mean, think about like if you somehow could like, I don't know, cache something that was like a popular search on Google, right? Like all the people who searched that would get what you were able to like poison that cache with. So we know the Easter Bunny is going to hit this reverse proxy. Maybe there's a way for us to poison that cache. And then when he goes to visit that letters, what he gets served is the page that has our that base URL. Like if we go back and look at, right, like if we look at the source code to this, right, it got generated with that site we can control. So if we could somehow get the Easter Bunny to get served this page or a page like this, then we would have a method then of getting our code to load on the Easter Bunny's browser. So now we could actually hack the Easter Bunny and not just hack ourselves. So let's go back to that, the code for the cache. Because like I said, there's all kind of different configurations you can use, like deciding what gets cached, how long it gets cached, all that stuff. And this is the file that's going to control all that. So this here is what's telling it. And so like you might be thinking like, how the hell am I supposed to know all this? Like, do you have to be an expert to like even just read this? This challenge is supposed to be easy. Well, like I can tell you when I did this challenge, I'd never heard of Varnish. I had no idea I mean, I've a lot of experience reading code, so I can kind of figure out what it means. And, some of it I think, most people can kind of just sort of understand. But like, I went to the documentation, I looked it up. Like, what is sub? Well, what is VCL hash? Like, what is VCL receive? Like, what does all this mean? And that's what you should be doing. That's like why you're watching this video, right? You're not just getting flags. Like, this challenge is retired. You're not getting points for it. Like, I assume you're doing the challenge because it's fun and you want to learn, and you're watching this video because you want to learn. So like, this is the things that go into learning. Like, you're just looking stuff up and learning things. Sounds kind of stupid to say it like that, but so that's what this kind of like is doing. Like, this is what's telling it, it's hashing it, and that's what's kind of giving it the identifier where, okay, anything that matches these hashes, like, serve that cache content. So like, it's using the request URL, which is essentially just the path, like \letters or \messages or whatever. And then the other one is the host or the server IP. And if those match the request, then it returns that cache content according to some other rules too. So like this here, this is just adding from the proxy before it goes to the back end. It's adding, an X forwarded URL header, X proto header. We can like read over these to try and figure out if this is sort of like what we're supposed to be doing. We can see here, this is the back end response. So it's using regular expressions to evaluate the URL. So what this is saying, if it's, so an upper caret means the start of the string and a $sign means the end of the string. So in this case, the URL would only just have this dash. So if the URL was just to the root or to letters, it's saying this is like the time to live. So basically what I think it's saying is for 60 seconds, send the cache content. If it's to message and it wasn't a 200 response, then send or cache send for 5 seconds. Otherwise, do it for 2 minutes. And then if it's static content, it's 2 minutes. And then this is inserting some headers to let the browser know whether or not it's getting a cache or not. Like if we go back into burp and we can see like this was a cache miss, right? So this was not cache content. But then for the next, where did I go? Submit. I don't remember what it's now, if that was how that worked. But essentially like letters, like this was a cache miss. So then the next, was it 2 minutes? Like you would get served this exact same document, anyone else who had it sent matching that host header. Well, we know that the EasterBunny, because we look at the bot, the EasterBunny is visiting, where is it? The EasterBunny is visiting 127.0.0.1/letters ID, whatever the next thing is. So we could poison this cache. There's a problem with it though. Like, so if we sent this request, like we could send a request to do the same thing we did on the one that we changed the host header to. We could change it to 127 blah, 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 blah. And actually here, let me just kind of demonstrate it. So like, let's say I want to poison it for blah, blah.net. Right? First time through, cache miss, tells you the age. Now anyone else, say I'm someone on the other side of the world who's doing the same thing, and somehow I'm going to blah, 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 blah net, and I'm requesting it. See, now it's a cache hit. So now it's getting served the cache content. But if you change anything in the host header, it's going to be a fresh response. Well, we know the EasterBunny is visiting 127.0.1. So we could, helps if I use periods and not quotes. Right? I just poisoned this cache. So for the next 2 minutes or whatever, anyone who goes to the EasterBunny, if the EasterBunny went to this page, because he's entering it in as 127.0.0.1, he is going to get served this exact page, and it has this base URL. Now again, here's the problem, right? Like, we don't control this server. We can't If somehow we could add our malicious code to the server, we could pwn the Easter Bunny. But the problem with that is if we could do that, we wouldn't even need to poison the cache. We could just do it a bazillion easier ways. But the point is still the same. Like, we have the ability to poison this cache. We just need a way to poison it so that he goes to where we want him to go. So again, what was I talking about earlier? Like, go through the code. If you don't know 100% what something does, look it up. And so we know the thing we can control and that we want to change to have it go where we want is this request hostname. But how do we get it to a place that we can control that the Easter Bunny also goes to? Because we know the Easter Bunny is going to go to the host of 127.0.0.1. What do? Well, do we know exactly what this request hostname function is doing? Like, I mean, we think we do, but let's actually look it up, right? We're using Express, it's Node. There's documentation for all this stuff. So we can go to the Node website and see request hostname, what this function does. And it says, contains the host name derived from the host HTTP header. Like, exactly what we thought. But when the trust proxy setting does not evaluate to false, this property will instead get the value from the X forwarded host header field. That's a big thing. And also, if we look in our code, like, so that's the condition, right? We need a trust proxy setting not evaluated to false. If we go back into that index that was setting up all the stuff, we see there's this trust proxy. It's being set, and it's being set based on this proxy environment variable, which we can assume is true because, you know, we're using a proxy. There's a proxy in place here. So most likely they set it to true. So that's actually a big thing, because what it means now is, let's go back into, we could set this to whatever. Like, let's go back to our initial blah blah, right? Someone registered blah blah blah.net, and they're running this code, and they're also getting letters to the Easter Bunny. So we know when we send that request, it's going to get, this would be blah blah. But now we also know that it's going to use the X forwarded host header. So now if we change that to that site that we controlled, oops, right? And we sent a request there. Oh, that did not work. Did I? Oh, yeah, it did. So we can see now it's not using the blah, blah, blah for this base ref. It's using the X forwarded host that we first put in. And then this is getting cached based on the criteria of anyone that goes to this URL with this host header gets served this page for the next, what was it, 2 minutes, 60 seconds, whatever it was. So let's look, right? We can't get the Easter Bunny to send this header or anyone to send that header, but they're just going to send this normal request. But look what happens. It still contains that string. So now we have a way, right? We could put that 127. We can poison the cache for the Easter Bunny just like we did before. But now we can add, when we poison it, we're going to add the X forwarded host header to get that line to go where we want to go. All right, so putting that all together to hopefully help it make sense in our head, we know that when we submit a request, the Easter Bunny is going to, whatever the URL is for the last letter, if we then, because we know where he's going, we poison that page so that he gets served the content from the cache that we've poisoned. He will then go to the relative URL that we can control to load all the resources. So we can get JavaScript to load on his computer that we can then use to read this message, or the message that we want him to read, because he's able to pass the checks because he's coming from this IP and he has the correct cookie and secret. And then we can send that to ourselves. So what we're going to do is we know the next time we submit, we're going to go to, so like 7 was valid, I think 8 was. So there is no 8. So the next time we submit, let's go ahead and load that up. So if we go submit, let's put that to repeater so we have it. The next message we submit, hello, Easter Bunny, is going to cause the Easter Bunny to go to this page, letters ID 8, to this host, and we can use our X forwarded host to the IP we control to load that JavaScript. So what we need to do then is have that JavaScript handy. Now, one thing we're gonna do, because we want to be super sneaky hackers, right? Remember when the Easter Bunny went to that page or like when we poisoned that page and like nothing loaded correctly because it was trying to get all the resources that weren't there? We don't want the Easter Bunny to be like, oh, what's going on here? Like, we can still get the flag, like, but just to be more clever, we don't want the Easter Bunny to go to like Easter Bunny Village IT tech support and be like, hey, what happened here? And then they look into it and be like, oh no, like you look at this request and that went out and someone stole our secret flag. So let's have it serve exactly everything it would serve if it was from the actual server. So the Easter Bunny looks, it's not going to look any different to the Easter Bunny. So I went ahead and already copied that over. So I need to remove the static that we created earlier, and then move dot static to static. So now I have the static that is exactly the same as the one that's on the server, and we're just going to change the view letters to add some JavaScript in it that will get it to do what we want to do. So let's just change it with Vim. So we'll have it go right before load letters. And what we're gonna have the Easter Bunny do is we're gonna send a fetch request to, 127.0.0.1. And what was it? Was it message or messages? Look at the code. It was message. What am I doing? Here's where I always spell something wrong and then screw the video up. Message 3. And then we are going to send it to, we want to take the response and turn it into JSON. And then we want to take that and send another fetch request, this time to a site we control, right? We'll use that same one, HTTP, the IP. Oops. We'll have it do flag equals, I want to make a template string because, did I do that right? Yeah. We want it to be the data.message. I think that was it. And we'll close that off. And then we can close that and that. And I believe that should work. Odds are probably low because I'm sure I typed something wrong. And then we are going to save this. And we'll start up our Python server on port 80. All right, so now we are going to poison the cache. Then we get 60 seconds to hit submit. So we got the forwarded host to the right one with okay, so there's a cast miss, and then now we are going to submit our letter to the Easter Bunny. And if we did all that correctly, which I apparently did not do, so Easter Bunny visited this stuff, but somehow I messed up the fetch request. What did I do wrong? Fetch. Oh, I didn't close off this string. See, I knew I was going to do something wrong. Kind of oh shoot. Insert. All right, take two. Let's fire that back up. Now we know the Easter Bunny is going to go to ID 9. And so let's poison this one. And then hello again, Easter Bunny. And let's see. Let's see if it worked. All right, there. Now we got it. So there we go. Okay, so hopefully that all made sense. Hopefully you learned something. Hopefully you enjoyed the video. If that is the case, it'd really mean a lot if you liked or subscribed, or both. And yeah, I don't know. Hopefully, yeah, that's it, I guess. That's all I got. Take care, and I'll see you guys in the next one.